All right, we're going to do the 8C notes right now. We're going to probably break Unit 8 into two parts for the video lecture here. But what is nice is the homework assignments are getting shorter. There's only 21 questions in this homework, so that should be a bonus to people. They'll go pretty quickly. So we're going to be using the principle of powers rules. And basically what that says is if A equals B, if I raise both of these things to the same exponent, it's still true. Just like when we had the equations, I divide each side by the same number, it's true. I multiply each side by the same number, it's true. As long as I'm doing the same thing to both sides of the equation, it will still be true. So we're going to try to solve with radical equations here. So the first thing to do is isolate one of the radical terms. Now there is only one radical term in this, and I don't think we get into multiple ones like that, so we shouldn't have to worry about that. So if I want to get the square root here by itself, I have to add 2 to each side. So then it's 8x minus 13 equals 3. Now, since the radical is by itself, I want to use the principle of powers. Since this is square rooting, the opposite of square rooting is squaring. So I'm going to square each side. So if I'm squaring the square root here, it's just going to be 8x minus 13 equals 9. Now what is nice about this one, if there's a radical remaining, we got to do A and B again. Well, it does not remain, so we're good to go. So now I need to solve. So I'm going to add 13, and so I get 8x equals 22, 8, and so I get 22 over 8, which is really 11/4. Now I do have to check to see if this works. So I have to put this in the calculator. I'm going to do the square root of 8 times 11/4 minus 13. And when I type that into my calculator, 8/4 minus 13 equals 3. So I do 3 minus 2, does it equal 1? Yes, it does, so this answer checks. And we'll do some more of those in a minute or two. But that's basically what the powers of rules here is. I did one of these, and we'll do some more of these in a bit. Now, we're going to bring in i's. I mentioned this in the 8a lecture. But the I is equal to square root of -1. I squared is -1. So we're really going to learn how to do like -5. I'm going to split that into 5 times -1, which is really the square root of 5 times I. You can write it this way, or you can put the I out front. As long as the I is not under the square root, we're good. When it has real numbers and imaginary numbers, it's called a complex number. And we'll have some of those. This formula, you'll have to know this formula. It's really not too bad, but you just got to remember how to do it. And then, my goodness, let the calculator do its business here. All right, so now we're going to start getting our first problems here. Now, the first thing we got to do is isolate the radical. It's already isolated, so that's easy enough. So I can square each side to start. So I get 3y plus 12 is equal to 4. Okay. So I'm going to subtract 12 from each side. I get 3y equals -8. Divide each side by 3, I get y equals -8/3. Alrighty. So now I should check this. I'm do the square root of 3 times -8/3 plus 12, put that in parentheses. Does it equal 2? Well, the 3's cancel. -8 plus 12 is 4. The square root of 4 is 2, so this checks. So this is the correct answer. Now this next one, they love to try to throw this in and trick you. Can the square root be equal to a negative number? No. When there's no sign out here, it's implying it wants the positive root. Now, if it had started with a negative out there, yes, I could do it, but there is no negative there. So this answer is a trick question. There's no solution. Okay. This next one, we got two fractions ones in a row. So now, no one likes fractions, and I want to get rid of the fractions. So the only denominator here, well, there's two ways to do this. One, we can look at this way and cross multiply. That's actually a better way to do it. 5 radical 1 is equal to 1. So I divide each side by 5, so the square root of y is equal to 1/5. If I square each side to get rid of the radical, I get y equals 1/25. And if I check that out, 1 over the square root of 1/25, and just plug it into your calculator, and you do get 5. So again here, I'm going to do this cross multiplying, so I get -2 3 root x is equal to 1. Divide each side by -2. I get the cube root of x is equal to -1/2. Now, some people will put no solution down here, but remember, this is an odd index. Odd indexes can be negative. So what's the opposite of cube rooting something? Well, it's raising it to the third power. So this is really x equals -1/8. So now, if I type in the 1 over the cube root of -1/8, I do get -2. So this is a good answer. It checks. Alrighty, now here are two questions that are going to be a little rougher than the rest. Giving myself extra space, and we're going to work this one out. So we have to first isolate the radical first of all, but then also when we notice here -1, -1, I have a variable on the left hand side, not a number. So this is going to cause extra problems. X minus 1 equals the square root of x plus 5. Now I have to square each side. And I'm hoping you can see where this is going to get ugly. Because x minus 1 squared, that means I have to FOIL it out, don't I? So I FOIL it out. I get x squared minus 1x plus 1 equals the square root here of x plus 5 squared is just x plus 5. So the x squared is not going away, so I have to bring over this. Well, let me combine my like terms. So I'm going to subtract x over, and I'm going to subtract 5 over. So I'm left with x squared minus 3x minus 4 equals 0. So now this is where I have to do my factoring. What factors of -4 add up to -3? Well, 1 and 4, I got to make this one positive, that negative. So that means it's going to be x minus 4, x plus 1 equals 0. So I let x minus 4 equals 0, so I get positive 4. And if I let x plus 1 equals 0, I'm going to subtract 1, and I get x equals -1. Oops, forgot to finish that out. So now we got to check our answers. That's again what makes this so long, because both may work and both may not work. We got to check. So let's do 4 first. I'm going to put that in the original equation. So that means it's going to be 4 equals, I'm going to change the color on this. 4 equals the square root of 4 plus 5 plus 1. So 4 equals the square root of 9 plus 1. 4 equals 3 plus 1. Well, that's true. So 4 is a good answer. Now, let's try to put -1 in. -1 equals -1 plus 5 plus 1. So -1 equals -1 plus 5, so that's the square root of 4 plus 1. -2 plus 1, -1. Well, that does not equal 3, so this does not work. This is my only answer I get. X equals 4. So you have to do a check on these. So this one's going to be very similar. To subtract 1 over, so does the 4 root x minus 1 equals x minus 1. So now, I really got to isolate this, but this is multiplication 4 times it. Now if I divide by 4, I'm going to have terrible fractions. So I have to be careful when I square this here on the other side. Now I just did x minus 1 squared right over on the other side, and I got x squared minus 2x plus 1. When I do this, I do 4 squared is 16, but the square root of x minus 1 is just x minus 1. So when I do this, I have to distribute my 16x minus 16 equals x squared minus 2x plus 1. I have my x squared here, so I'm stuck with it. So I'm going to subtract 16x, and I'm going to add 16. Then I get 0 equals x squared minus 18x plus 17. So what factors of positive 17 add up to negative 18? Well, that's easy enough. X minus 1, x minus 17. So when I let each equal to 0, add 1, I get x equals 1 as one possibility. Add 17, I get x equals 17 as my other possibility. Now, let's see if they work in there. Change my color here. So, we're going to do 4 times, square root of 1 minus 1 plus 1. Does it equal 1? Because what I did, x equals 1, I just put 1 in there. So this is 1 minus 1 is 0. Well, 4 times 0 is 0. So 0 plus 1 does equal 1, so this is a good answer. Now let's try 17. 4 times 17 minus 1 plus 1, does it equal 17? So 4 times the square root of 16 plus 1, does it equal 17? Well, 4 times 4 plus 1 was 16 plus 1 does equal 17, so actually they both work, don't they? So one time, only one of the answers works, and the other time, both answers works. And that's why you got to check it out. After those 2 extremely long questions, this is going to be the end of the first half of the 8C notes.